Hello and welcome in, everyone. My name is Brian, and I'm here checking in to see how you guys are getting along this fantastic April. Nice, hello. Yes, it is. Some might even call it Zeta Thrilling. How are you doing today? I've had a ridiculously long day. It started super early. I had meetings. We're hiring people at the college, so we had to get together, talk about all the hiring stuff. I had to take my dog to the groomer today. So, I mean, at least my dog is having a great day. So, I'm ready for bed. I'm so tired, and it's only 5 o'clock. But at least it's been a productive day, which is nice. Could be better, you say. Could be better. If you want, you are always welcome to share, and we can bitch and complain about stuff if you want to. Sensation, hello, how are you doing, man? Long time no chat. I feel like it's been a while. I've been super busy. I'm actually pretty close to being done the first book, which is pretty exciting. And once that launches, we can start talking about YouTube stuff. What is this? Batman of the Future. That was a... What? This was a cartoon? Batman of the Future. Oh, I remember Batman Beyond. Yeah, Batman Beyond was great. It actually was really fantastic. I never watched it. Not in English, though. Yep, I remember it. Totally remember it as Batman Beyond. Yeah, I watched this as a kid. It was fantastic. It was a great show. They should bring it back. Did it end? I didn't watch the ending. I don't know how it ended. So here we are, friends. Here we are, working on this mathematics contest. 8B. I wasn't sure how to start this, so we have an x value in between 0 and pi by 2, where cosine of 3/2 cosine x is equal to sine of 3/2 sine of x. And we want to find all the values of sine of 2x. And I had no idea how to start this question. And I had to look up a little tiny hint. And it makes sense in retrospect, I guess. It makes sense in retrospect, but the hint was, if we have something that looks like cosine of an angle plus sine of an angle, the two angles have to add up to 90 degrees. They have to. And I wonder if we could convince ourselves that that's true. They made a movie. I think they tied up loose ends in Justice League Unlimited. Oh, okay, yeah. I do remember the movie. I don't remember watching the movie, but I do remember the movie. I'm trying to think what I would have transitioned into. That was when I was pretty young. I feel like I would have been in high school when that was out. And then I probably transitioned into the Xbox, and I probably played a lot of Halo. I feel like that's how I transitioned out of Batman Beyond. Is this true? Okay, so let's say that we have the unit circle or something like that. And I have a point on the unit circle, and I'm pretty sure the cosine comes first, right? But this is if it's the same angle. So this means that along the x-axis we've moved cosine theta units, and along the y-axis we've moved sine theta units, right? That's what the unit circle says. And what else do we know? We know that theta is going to pop up here as well. So the other angle, I don't really know what it's called, but there is another angle inside of this triangle. It's called alpha. And I suppose... Is it obvious? It's obvious that theta plus alpha is 90 degrees. That's obvious. What is... Okay, so we need to show that cosine of an angle plus sine of the different angle implies that these two angles should equal 90. I don't know if I can imply this all the time, but I do know that cosine of theta would be... if we label this as x and y, cosine of theta would be x over 1, right? The adjacent side. And we know that sine of the other angle should be the opposite. Over the hypotenuse. I must be reading the hint wrong here inside the solution key. Let me take a look again. So, if y and z are angles... Oh, it's when the equality is true. It's when the equality is true. So, it's if these things are equal... This implies that x plus y is 90 degrees. Okay. That I didn't know. Oh my gosh, are you really trying to... Are you pulling a pun? Are you pulling a pun? It's beyond you? Beyond? I wish I could have seen the future of that joke. Anyway. My goodness. 5 p.m. on a Thursday evening, and I'm getting dad joked. You know you're in for a good Thursday when that's happening. You know you're in for a good Thursday. Oh man, okay, so how do I convince myself that that's true all the time? Cosine of x, when cosine of x equals sine of y, then the sum has to be 90 degrees. Really? Oh, it's right here. Oh my gosh, it's literally staring me in the face. Okay, so both of these things, so here, if I look at this, I have x is equal to cosine theta, and I have x is also equal to sine theta, and here I know that alpha plus theta is equal to 90 degrees. Okay, so I've convinced myself using the unit circle that that's true. Oh my goodness. Loims, yes, I know. I tried to put this out of my mind too, but I think we can actually solve it. I think it's relatively straightforward once we use this idea. Offset, hello, welcome on in. How you doing? My math teacher just published the math test. What math test? Send me the link. Let's do the math test. I think we got it. I think we can do this now. So I've convinced myself that if I take cosine theta inside of this, I'm going to highlight it in blue, inside of this triangle, so cosine of theta inside of this triangle is the adjacent side over the hypotenuse, which is x over 1. And if I take sine of alpha inside of this right angled triangle, then I get the opposite side, which is also length x, divided by 1. Since both of these things are equal to x, I can set them equal to each other, so I get the relationship that the two angles have to add up to 90 degrees. How weird is that? That's so weird. Kind of cool, though. I did not know that. I guess it only works here, though. I guess it only works when x is between 0 and pi by 2. Keep in mind, it is in Spanish. That's okay. Math is math. One time, I did calculus in Vietnamese, and that was probably the hardest thing I've ever done. So this is what we have, right? We have something that looks like this. So this implies that 3/2 cosine x plus 3/2 sine x should be equal to 90 degrees, which I'm going to write as pi by 2 because they want us to give a specific format for the solution. ¿Dónde está la biblioteca? I don't know. I haven't seen the library in a while. So if that's true, can we just multiply everything by 2/3, and that's going to give us cosine x plus sine of x is equal to pi over 3? Pi over 3? Good pronunciation. Oh, thank you very much. Thank you. I teach a couple of Spanish students in my college, and they keep me on my toes. I find Spanish is a lot like French. Once you kind of understand the mouth formations for how to speak French, Spanish isn't that difficult. And I mean, humble brag, but the last time I was in France, they thought I was native. Humble brag time. Okay. I think we square both sides, because I know that cosine squared plus sine squared is going to vanish and give us 1. And I think the cross term here is going to be the sine 2x that we need. So this will give us cosine squared x plus a sine squared x plus the 2 times cos times sine. And that's pi squared over 9. This is exactly what we want. This is sine of 2x. And all of this is 1. So here it is. I think we need that sine. So we have sine 2x is equal to pi squared over 9 minus 1. But we need to... I think we need to... Oh, did I do something wrong? So why isn't it that, is it that 3/2 goes into the pi over 2 and we don't get 3 pi over 4? Because I'm multiplying actually by its reciprocal. Yeah, sure, you can post it in general chat. That sounds fantastic. I'm always curious to know what people are learning, mathematical-wise. Does that clear up your question there, Loims? So I think we get the 2's cancel, right? And we get the 3. Hey, honestly, like, it's been a long day. I could very easily make a mistake. So keep watching what I do. You've seen me answer some of these questions. It's very easy to make very simple mistakes on these contest questions. But yeah, I think we're good up to here, I think. And then what form do they want? They want a pi squared plus b pi plus c over d. Blech. Okay. So I guess we just make this pi squared minus 9 over 9. that all they want? Is that what they want? So A equals 1, B equals 0, C equals -9, and D equals 9? Seems weird, but okay. I thought that's okay. You said cosine x plus sine x is equal to pi over 2. That is not correct. I mean, there are certain x values where that works, but we are rolling with the following. We are rolling with if cos equals sine and we have two different angles inside, then the sum of those angles has to be equal to 90 degrees. So it's actually these inside pieces that we're working with. So the sum of these two things that I've circled in red are going to be x and y. When we add those up, we should get pi by 2. And I personally didn't want to work with the 3/2, so I just divided everything by 3/2. Yeah, so it's I think the way you're thinking about the question is backwards. If that makes sense. I don't know if that makes sense or not. Your logic is just going in the reverse direction, that's all. Okay, I think that's it. I think that's all they want. I think that they just want the value for sine 2x. So let's have a peek. Okay, blah, 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 blah. Okay, do this. Square it, get your sine 2x. Yeah, cool. Okay, so we get pi squared minus 9 over 9. What a bizarre question that is. And that's such a weird relationship for cosine and sine. I actually had no idea that that relationship was true. So weird. All right, we gotta go grab some chicken. Yeah, it's true, yeah. Chicken will help with the doing of the maths. Let's see, can we actually find... Ah, here it is, excellent. Oh, yes. Oh, vectors? Vectors and matrices? Heck yeah. I have no idea what some of these words mean, but we're going to do these questions today. I'm so excited. And I just can't hide it. I might start to lose control. Okay, in the meantime, while we're waiting for Offsad to get back, let's start into the Euclid 2019. This is 8A. Everybody's favorite. Looks like more geometry. Oh my goodness, why? Why is there so much geometry on this particular test? No. No. This test is testing my patience. That's what it's doing. So just as a reminder for those of you who are watching, if you do have some math questions, you can do just like Offsad did. We can post those questions into the Discord server that we have, and then we can answer those questions together on stream. And if I'm not streaming, you can still post them. And then maybe somebody will come along and offer some help. We have a really cool community over there that is willing to help out with some of those questions. Please, please ask all of the questions. We're done with geometry. Geometry needs to go away. Yeah. Let's see. I mean, it's only question 8 of 10. It might be an easy geometry question. I don't know. I don't know. Maybe it'll be easy. The circle has center 0. Oh my gosh, I'm lost already. Oh, center 0. What? Oh, center O and radius 1. Okay, quadrilateral ABCD has all 4 sides tangent to the circle at P, Q, S, and T. Oh, we know some stuff about angles. This could be helpful. So AOB, BOC, COD, and DOA are all equal to each other. So they're all 90 degrees? Right? That's all of these angles, isn't it? AOB, BOC, Call of Duty, Dead on Arrival. Yeah, okay, so if all 4 of these, we know that 4 times the angle is 360, so all of these angles have to be 90 degrees. Okay. From the tip of the circle to A is 2. That is yes, that is probably a good intuitive guess. So all we know is that this is 3. So that's all we know. Oh, you're right. So that does have to be 2 because we know that the radius of the circle is 1, right? Okay, yeah, I can get behind that. Okay, so we have, this is 2, this is 1. If we were to connect to T, for example, that would also be 1, wouldn't it? The only issue is I don't know any of the angles inside. So the advantage of being able to connect to D is that we know that that's a 90-degree angle and we can do Pythagoras' theorem. I wonder... I wonder if we zoom in on this picture, if that's going to be helpful. Yep, so we know that this is 90 degrees. We know that A is here. And at some point, this is D down here. This is a very bad drawing, but we have something like this, right? If we zoom in, and we know that this is going to be 2 and this is going to be 1, and then there's going to be like a little bit down here, I don't really know what that is, and then this is going to be 1 as well. So could we, and what's the point, what's the goal here? The goal is to get length ds. ds and dt should have the same distance, right? Those should be the same distances. No, not necessarily, I guess. Chicken has been served. Yes, chicken to the rescue. Oh my goodness. Okay, we can move away from this. Move away from this question for a second. I'm just going to make a little note here that all of these are 90 degrees. So that when we eventually come back and tackle question number 8, we will have that note written down. Now, the question is, can we figure out how to do math in Spanish? It's like doing math in English, but sexier. How do you pronounce EJE? What does that sound like? Is it like ejercicio? Because the ci would be like a c. Like, oh no. I don't know. I don't know. I'm more so curious about how to pronounce it. So exercise number 1. Okay, so we have the following vectors. So A, B, and C are given. Let's convert B into its component form. So -3, 4, and -6. And it wants us to calculate some stuff. Okay, this doesn't seem too bad. The length or the magnitude of A. We got this, we got this. A here, sitio, here. Oh, so the J is like a h here. Here. Cool, okay, I didn't know that. Thank you, Sensation. I knew I could count on you, Mr. Dual Language Citizen. No, that totally makes sense. I was just curious. It was my own curiosity, that's all. Okay, so about A here. How do I find the magnitude again? Magnitude is I have to square everything, right? Do something like this. So we need 4, 9. 4 plus 9 is 13. Plus another 1 is 14. So root 14. And that doesn't simplify. Magnitude of B is going to be 9 plus 16 plus 36. 9 and 16 is 25. 25. 61. In the Scottish accent when I speak foreign languages, lots of throat sounds and rolled R's. Yeah, that was the hardest part as an English speaker, was to get the trilled R, and I'm still not that great at it. And so I think it's 61, right? 9. What's the hardest you're learning? Is it Japanese that you're learning, Sensation? Is it Japanese or Mandarin? I think it's Japanese, right? Yeah, that's 61. Okay, and then we need 16 plus, oh, my favorite number. Here it is, 17. Boom. C. Oh, how precious you are. That is correct, Loins. These are the lengths or the magnitudes of the vector. That's correct. So if we were to, it's going to, I'm not very good at drawing things in 3 dimensions, but if we were to draw these vectors in a 3-dimensional viewing window, it would tell us the distance from the origin to wherever the tail end of that vector is, wherever it's pointing. So for example, 2, 3, and -1, we'd have to, I don't know how people label their axes. We'd have to decide on which way we want to label stuff, but let's say we go X, Y, Z. So we'd move 2 in the X direction, boop, boop. We'd move 3 in the Y direction, doop, doop, doop. And then we'd move -1 in the Z direction. So that's what our vector looks like, and we get the root 14 is the length of that distance. All right, looks like I have a couple ads rolling. I'm just gonna chill out for like a hot second, think about question number 2. If no ad, oh nice, you win the game. I always watch with another account just to know when the ads pop up and to see kind of like how my... I like seeing how StreamerBot interacts with the ads as well. But I'm curious to know about this B dot C. I think this is going to be the dot product of B and C. But hopefully that diagram made sense, Limes. You kind of like, usually you start the vector at the origin and then you kind of use the components to kind of draw it.
Deliver perfect results.
Sensation! With the resubscription. Oh my goodness. Thank you very much, my friend. Much appreciated, much appreciated. Enjoy the ad-free viewing. You also have access to the 8-ball command, by the way. No one's used it yet. Exclamation mark 8-ball and question if you want to give it a shot. Shake, 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 shake. What the fuck? Might have to lower your slope. Just saying. Anyway, thanks for testing it out and making sure it actually works on stream. Much appreciated. Enjoy your magic 8-ball questions. Well, I feel like I got bored one Saturday, and I was like, I'm just gonna make this and see what happens. Lauren, did you answer my direction question? Basically, the components give you, the components will tell you kind of. I always think about it as where the vector starts, 0, 0, 0, and where the vector ends, 2, 3, -1. And with that information, you can figure out how long the vector is, how long the arrow is, and you can also figure out what kind of angles it makes with the, in this case, the planes. Levi, hello, welcome on in, my friend. How's your Thursday going? Yeah, we're doing a little bit of linear algebra in Spanish. Oh, guess what, Limes? Guess what? I have a feeling we're gonna have to calculate some angles. That kind of looks like the word angle. Oh, seriously? Do all calculations with an abacus for an amount of time? Oh my gosh. I don't think I've ever used an abacus. It's sad to say. Very sad to say. I do have a question for you. Is B dot C, is this the dot product of B and C? And if that's the case, what does this mean? Oh no, this is going to be... The dot product will give us a scalar, so this will be a scalar times A, and then we need 2 times B. Okay, we can do this. So what is B dot C? This is going to be -3 times -1 plus 4 times 0 plus -6 times 4. So what this question is really asking for is what? 3 plus 0, so we need 3 minus 24, which is -21. We need -21 A's and 2 B's. Two, 3 minus 1, 2, 3 minus 1. And -3, 4, -6. For some reason, I was reading that last comment you posted, Levi, and I was like, I have an abacus, and I read it as a saucepan, technically, and I was like, why does he want to give me a saucepan? Yeah, there are two ways. Yeah, two ways to calculate the dot product. We can calculate the dot product by doing AB cosine theta. That is true. The much faster way to do the dot product is to multiply component by component. So in this case, we wanted B dot C. So we basically go component by component. So for example, I'll multiply the two red ones together, then multiply the two blue ones together, and then multiply the three green ones together. This is also a valid way of calculating the dot product. It's the same as taking the lengths and multiplying them together and multiplying by cosine theta. So that's what this big old multiplication was up here. That was calculating the dot product. So I think, what do we need here? So we need negative, this number is so big. 21 times 2. Negative 42 minus 6. My brain no worky no more today. Brain no worky no more. 21 times 3. So negative 63 plus 8, right? Negative 63. Nope. Stop. Negative 63 plus 8. And then 21 minus 12. 21 minus 12. So that's what I'm thinking for number 2. Okay, I'm just going to drop them down up top so that we can, use some space so that people can actually see what's going on with the question too. Let's try number 3. Number 3 has a cross product in it. That's exciting. It's been a while since I've taken a cross product. Oh no. So are there different types of abacuses? Is that for calculating some zesty sauces? Nice. So what is a saucepan? Okay, can Brian remember how to do the dot product? I think I am old school and I use determinants. So A cross B should be 2, 3, minus 1 first, and then negative 3, 4, minus 6 second. And let's see, so I think we have to do negative 18i. I think all of these get added, right? 3 J's, 8 K's, 1, 2, and 3, and then we do the backward stuff. So we need to subtract the next bunch of stuff. So subtract. So you're kind of, I think, so I'm used to doing like diagonals. I feel like there's a formula for this too, but nobody likes formulas. So I've always done it like this, where I just make like 3 multiplications this way, those are all added, and then 3 multiplications this way, and those are subtracted. I don't know, maybe I'm old school. What 17 page? Oh, it's a special type of abacuses? Abaci? What's the plural of abacus? Abacacy? So is that right? So negative 18i plus 3j plus 8k, right? And then we need to subtract. We need to subtract negative 9k. We need to subtract negative 4i. And we need to subtract negative 12j. So we get 15 j's, we get 17 another, and that, look at that, a good number. And then we get negative 18 plus 4, so negative 14 i's. So to finish B, I guess, the cross product of these two things, minus 3 c's. So let's take the components of negative 14, 15, and 17 and subtract 3 copies of c. So negative 3, 0, and 12. And what do we get here? We're going to get negative 14 plus 3, and get 15 minus 0, and then 17 minus 12, which is 5. Oh, look at that. I love avocado. I don't know if I would put avocado on my abacus, but I think they could share the same vicinity and that would be okay. The swanpan has, say, like 10 to 20 rows or whatever, but within each row it's broken into 2 sides. Okay, one side contains 2 beads that holds a value of 5, and the other side contains 5 beads that hold a value of 1. That's weird. It breaks everything up by 5s, is what you're saying. So an 8 would have a 5 and 3 1s, and as soon as you get to needing the other, as soon as you get up to 10, you do your 2 beads, I guess, right? Weird. Kind of cool, though. So for some reason, 5 was important to them. That's basically what that relic tells me. For some reason, 5 was important. They needed to put that on their abacus. Okay, offside, I'm going to need your help here. Okay, what angle are we calculating? Something in the direction of A. So the angle of something in the direction of A. The angle, the cosine, that looks like cosine, but what does that mean? What does that mean? Oh, what is it? The angle, okay. The angles and cosines director of A. What the fuck does that mean? What the heck does that mean? So direction, so for the angles and is this like cosine? And cosine, probably the teacher made a typo. I don't know. Okay, the angles and cosine direction of A. The angle and cosine direction of A. I'm not sure what that means. Do you have an idea? Levi, what does that want? I guess we could... It probably has something to do with the angle that it makes with one of the planes. So direction, cosines, and angles, yeah. My brother, I only speak American. I believe they call it English, but sure, okay. we might have to go and look this up. So can we find the so given a vector in 3D. Need to find the angles and cosine directions. Direction cosine, that sounds like a thing we want. Okay, here they are. The direction cosines, let A be the angle between V and X. B the angle between V and Y, and C the angle between V and Z. The direction cosines equivalent to the X, Y, Z coordinates of a unit vector are this. Huh? Maybe this isn't what I want. Oh no, I see. X hat, Y hat, and Z hat, these are unit vectors. This must be what we're looking for, right? We take the vector, we turn it into a unit vector, and then we multiply it, or we dot product it with but how do I know what those angles are? Like I used to say to my students, do whatever it makes sense to do. I feel like this is probably the thing that we need to do. Right, so we turn V into a unit vector, that makes sense. If we find, yeah, if we dot it with the unit vector along the x-axis, then yeah, this is the definition of cosine of A. So we could solve for A. Yeah, okay, I think this makes sense. So I'm thinking we could do something like this. So we could take A, we could divide by its magnitude, which we know what it is. So A divided by its magnitude would be 2 over root 14, 3 over root 14, and negative 1 over root 14. So now it's a unit vector. And so if we want to find cosine, I'm going to call it cosine x. So x is going to represent the angle that we make with, that still doesn't make any sense to me. No, that makes sense. It'll be the angle that this makes with the x-axis, right? The positive x-axis. So what we need to do is we need to, let's call this like a unit. So we would dot product this unit vector with this one. And, you know, technically we would divide by their two magnitudes, but their two magnitudes are both 1. They're both unit vectors. And so the dot product's just going to give us this. Okay, so we know that cosine in the y direction is going to be 3 over root 14, and cosine in the z direction should be negative 1 over root 14. And so I guess we could probably try to apply cosine inverse to these. That seems like a thing we can do, right? Is that a thing we can do? Calculator? Calculator? Click SMR, here it comes. Click SMR, everyone's favorite time of the day. 2 over root 14, question mark? Is this gonna come out to be something that makes sense? 57.69. Am I in degrees or radians? I'm hoping I'm in degrees. Yes, I'm in degrees, okay. I think that makes sense. I think that makes sense. And then I can just update these and change them around a little bit to calculate the other ones. So this one would be 314, or sorry, 3 over root 14, so that's going to give us about 36.7. This is my best guess. I don't know if I've ever actually played around with these particular angles before. Oop. So 105.5. Sounds like it should be like a radio station. Okay, so now I'm picturing, what is this? Have you ever seen the Brad Pitt clip? This is an American tank, and this tank we speak American. And if you want to speak Mexican, go join a Mexican tank. I have not, I can't say I have seen the movie Furry. I mean Fury. It must be Fury. And now I'm just picturing one tank painted in the stars and stripes and the other in the big sombrero. With like one of those big like nacho hats. What is this? Furry is the Wish version of Fury? Like you wish that movie existed? I mean, do we really want to see, who is it? Do we really want to see Brad Pitt dressed up like that? Probably not. My guess is no. How'd we do? How'd we do with exercise number 1? Do we know the answers? Or is it just gonna be, we're just taking a guess? Do we know what the answers are? So I think that was exercise number 1, right? Exercise number 1. Exercise number 2. Let us know. Let us know if we did good or didn't do good. Oh, answers will be up next week. Okay, well, please update us next week when we know what the answers are. Trust your instincts. Okay, what's this? Con los vectores. Okay, something about the vectors in the... Okay, what set of vectors are we working with? With the vectors of exercise 1. Okay, I was wondering if it was asking us to use the previous exercise. Okay, so are A and B perpendicular? Are C and B perpendicular? Are they parallel? We can answer that. So we need A and B. So the easiest way to answer part 1, if the dot product is 0, they have to be perpendicular, right? So if A dot B is equal to 0, we'll have our answer. So we just need to grab the values here and do this dot product. So 2, 3, and -1. And what do we need to dot that with? -3, 4, and -6. -3, 4, and -6. Drum roll. Okay, -6 plus 12 plus 6. Oh, fail. Darn. Let's double check numbers. Yeah, with that -1 and -6 at the tail end, they're just not quite gonna make it, are they? So not perpendicular. And what about C and B? So C and B. Let's take a look at those. I'm just going to bring them over. So we have -3, 4, -6. That's B. And what's C? C is -1, 0, and 4. What if we do a dot product of these things? So that would be 3 plus 0 plus negative minus 24. I think we did that already, right? I think we did that already, yeah. So we know that these are definitely not perpendicular. But how do you show if two vectors are parallel or not? How would we show that these vectors are parallel or not? I guess there's a couple ways we can do that. We could use the formula, right? So we could say that cosine of the angle between our two vectors would be b dot c over their lengths. And if they're parallel to each other, that means that the angle between them is either 0 or 180 degrees. So maybe just for sake of argument, let's use cosine of theta is equal to... Does it matter? I don't think it matters, right? We can take 0 degrees. 180 will do the same thing. So let's take that to be the case. We know that this numerator is negative 21. Then did we find the lengths of these already? I think we did, right? Found the lengths of them already. The lengths were root 61 and root 17. So now we ask the question, is it true that 1, which is cosine of 0, is that equal to negative 21 over 61 under the root 17 under the root? Is that equal? I don't think so. Something tells me that if I multiply 61 and 17 together and I apply the square root to that, I don't get negative 21. Just something in my heart tells me that I'm not going to be able to apply a square root and get a negative 21. So they can't be parallel either. Otherwise, if I take the dot product and divide by the lengths, I should get 1. It's kind of cool. So that's one way to do it. You can use the cosine formula. I guess the other easier way is to kind of look at the vectors and go, well, one of these vectors has a y component, so it's going off in the y direction by some kind of number by 4. The other vector doesn't really have any movement in y. So it's going to be pretty hard for us to find a multiple. It's also true that if I could take vector b and I could write it as a scalar multiple of vector c, then they're parallel. So if I could find a way to multiply c or multiply b and get to the other one, that would be another way to do this. Is this proof by something? Proof by something my heart tells me. Yeah, that reminds me of the text that you sent me today, Levi. Some of those are hilarious. I should see if I can find that. That was a really funny meme. It was like proof by plausibility. It sounds good, so it must be true. Proof by intimidation. Don't be stupid. Of course it's true.
Time for a pop quiz.
Shit like that. That was really funny. Proof by accident. Hey, what do we have here? It was such a good meme. I really, really like that. That was really funny. So that's so sad. We didn't get anything that was perpendicular. We didn't get anything that was parallel. Oh man, so sad. Okay, I guess the last thing we're doing today is we're doing a little bit of work with some matrices. Matrix time, boys. The best time of the day. Matrices. 3 times 14. I feel like I should know what that is. 3 times 14 is 30 plus 12, 42, and 8. 50. Nice. Nice. Yes, you will never escape matrices. It's very true. Oh, the worst part is we have to do matrix multiplication. I hope that some of these don't exist. Okay, matrix number 1. A plus 2B transpose. I love how chill this is. This is like exactly what I needed to finish off my Thursday. Okay, if we transpose B, we stick with 3, 0, 1, right? 5 goes here, 2 goes here, 0 goes here, 1 goes here, 1 and 0. And then I forgot to multiply by 2, but that's okay. So we should be able to kind of, I think, wrap this one up just mentally. So we have 1 plus 6 is 7. We have 2 plus 4, which is 6. The hardest part about matrices is you're just probably going to make an addition or subtraction mistake. Negative 3 and 10. So this is 10 minus 3, which is 7. 1, negative 1, negative 4, 2, and 1 plus 3? 1 plus 2, 3. It's totally, yeah. It's always something silly. That's always my outlook. I'm like, you always make a silly mistake. We can't add, not possible. And it looks like we have to give a justification. Obviously, matrix C and matrix A are not the same size, so we can't add component by component. Ooh, can we sneak through any of these multiplications? Tell me that we can sneak through at least one of the multiplications. This one's not possible. Right, A times D, because A has 3 columns, but D only has 2 rows, so we can't do that multiplication. But that unfortunately means we should be able to do the other ones. But okay. C times D, what does that look like? So this is 1, negative 1, negative 2, 1, 0, 1. And D is 5, 2, negative 3, negative 4. Okay, what's going to be the size of my new matrix? Max attitude. We need a max. We should get a max attitude emote. I need to start designing emotes. We need to get a few more emotes here. If you have some ideas for emotes, let me know. We do it, of course, in the show theme, right? That's usually what I try to do. So we have the obvious, we have the beautiful ban emote. We have the booba. We have if something is really exciting, you got the show booba emote. And you got the fired up emote. All designed and drawn by yours truly. Oh, and then of course we have Giga Show, we got the Chad emote, just, in case, I'm gonna show off something. I think an abacus would be a good one. Yeah, we should totally have an abacus emote. I gotta start thinking about this. I think this could be a good theme for the summer. Brian learns how to use an abacus. It's possible. It's possible that I could learn how to do such a thing. What's going to be the size here? If C is 3 by 2 and D is 2 by 2, then my result should be 3 by 2, right? So we're going to have 5 plus 3 is 8. We'll have 2 plus 4 is 6. Negative 10 minus 3 more. Negative 4 minus 4 more. Negative 3 and negative 4. So there is C times D. Not too bad. This next one's going to be a real pain in the ass. Multiplying 3 by 3 matrices. That's not fun. That's not fun at all. No one wants to do that. I guess at least there's a lot of zeros inside of matrix D. That's nice. Guest appearance by Levi on stream. Yeah, we have that. There's that thing now you can do. What's it called? It's called like guest star or something like that. It's like a new. Like you have your account, right? Like, and I can like invite you to like be a guest star or something on Twitch. I don't know how it works. I've never looked at it. It scares me a little bit. But yeah, if you want to come on and teach me how to use an abacus, that's fine. That'd be kind of fun. Oh man, 3. So man, I really have to be careful here. It's going to be a 3 by 3, so we need 3 minus 15 and 0. So 3 take away 15 is negative 12. Then we need 6 plus 5 plus 0, so that's 11. And then we need 0, we need negative 5 and 0, so negative 5 here. Yeah, so that should be row 1. Row number 2 is going to be 2, 0, and negative 2. So it'll be 0, 2, 0, and 0. So 4 in the middle, and 0, 0, 1. This is actually not as terrible as I thought it was going to be. 1, 0, and minus 2. So negative 1. We need 2, 0, and 0. And then we need 0, 0, 1. So I think that's going to be our multiplication b times a. Do you guys have any idea what this means? What does that mean? What's the magnitude of matrix A? How do you define the magnitude? Oh, is that the determinant? Oh, yeah, okay. Okay. Do I remember how to take the determinant of a 3 by 3 matrix? It means SOS. A cry for help. Let's do 8 first since it's the easiest. The determinant of matrix D is just going to be 5 times negative 4 minus 2 times negative 3. So it's this added, this subtracted. Easy peasy. So negative 20 plus 6. So this one should be, what, negative 14. That's the easy one. The other ones are going to be a bit more of a pain in the butt. But I'm kind of, I'm kind of partial to the cheating way, which is to basically just take the first 2 columns and rewrite it. And then just do the multiplications, right? We need the 3 positive multiplications and 3 negative multiplications. So this is determinant for matrix A should be 1 times 1 times 1, 2 times negative 1 times negative 2. So 2 times 2, that's 4. And then the third addition is going to be a 0. Our first subtraction is going to be a 0. Our second subtraction is a 0. And then our third subtraction should be negative 6. So 10, 11, I think, is going to be the determinant for A. And I guess we end with B. I feel like B is going to have a 0 determinant. Oh, maybe not. It just looked like there were so many zeros. So we get 0 plus 5 plus 0, minus 0, minus 0, minus 10. So 5 take away 10. Oh, we don't need to find determinant of B. Well, I did it anyway. I didn't see that it was determinant of C. I thought it was determinant of B. Okay. So determinant of C, I mean, we could probably devise a way to make it make sense, but in most normal linear algebra classes, you're just going to say that determinant doesn't exist because that is not a square matrix. So we don't really want to talk about determinants usually for non-square matrices. So there we go, a nice little introduction to some vector algebra, some matrix algebra. Yeah, and I feel like today we have earned a little bit of extra credit in Spanish. Look at us go, look at us go. What a cool community. I love being able to do math in different languages. It's a lot of fun. So thank you very much for the posted math test. Hopefully we get some solutions next week. Feel free to post them up into the Discord server. Once you have the solutions, we can double check our work. However, I think with that said, my friends, I think that's it for me for today. I will be back. It's going to be next week, though. So this Friday, I am canceling my stream tomorrow because, well, you know, I might be able to sneak in late, but I work from 2 to 7 tomorrow. So if I do stream tomorrow, it's going to be after I get back from other work, from working at the brewery. So we'll see how things go at the brewery. If I'm really tired or I just want to like have a beer after work, I may not stream. I'll let you know. I'll let you know how things are going tomorrow, and we might have a stream at 7. If not, I'll be back next week on Tuesday, and we'll do our staggered approach next week. So 1 o'clock, 3 o'clock, 5 o'clock, 7 o'clock as we move through the last couple weeks of April, just to try to cover all of the time slots here for final exams for students. Gracias. Thank you, Limes. Thank you, Offset. Thank you, Sensation. Thank you, Levi, coming and hanging out, having a good time. Always much appreciated. Thank you very much, Sensation, for the resubscription. Oh my goodness, you didn't have to do that. I will see you guys hopefully tomorrow, but if not, enjoy the weekend, and I will definitely see you guys next Tuesday. So stay positive and have a good night, guys.